code, right? Okay, that's it. Now it's also recording. Great. Okay, so libraries, as I was saying, is a collection wherein you will find functions which you can use to make your life a little easier, so you don't have to like code everything, right? So let's do an example. So there is, for example, if you need to use math functions, right? Like if you need to calculate the area of a square, then how do you calculate the area of a square? So, the area of a circle. The simple formula of an area of a circle is if you have a radius. So let's say we have a variable, we have a radius of 2 meters. Now, if we want to calculate the area, we would need something called as like pi. And then usually we have a value of 3.14. And then you do this, and then you do radius times radius. This is the area. This is not exact because we didn't use the value of pi the way we were supposed to. So there is this library called math. And how do we use libraries? We import it into our program. So we write import, which is by the color you can tell it's keyword. So Python understands that we are importing, like when we say import, then we want access to some library. And then we write the name of the library. So math is the name of the library. Okay, so that's what it is. So now we have access to this library called math. Now, what all functions does this library has? Like, what does this library, how much can this library offer us? So like a simple way to do that is generally if you're accessing a new library, say math and then dot. So what this dot represents is now you're going inside math. So math is just the library name, and then the dot is for accessing the functions inside of it, right? So like if you need a city name within a state, you will say, let's say up.agra or india.up.agra, right? So that's how you proceed. Now, if I do a tab, then this is what Python tells me. So like I just press tab. So the key tab, which is usually above caps lock in most laptops or most computers, that tab key, if you press that after you do math dot, then you will see these multiple functions that the library math has. And then we see, so here we have math.py, right? Now, if we, or so that's what we would need to calculate the area. But let's say if there is some, like, let's explore something else. Let's say there's so math.factorial. So how do we use that? And, how does that work? So if I choose math.factorial, and then I just press a question mark at the end of it. So this question mark is basically me asking Python to tell me what is math.factorial, right? And this tells me. So what does this tell me? It tells me that so this is what the signature is, math.factorial, and then it's a function because there are these curly brackets. So remember when we did functions with Saket, then we had these curly brackets at the end of the definition, and then you can pass something as a value or like as a parameter in the function. And then if you type x, if you pass x, then the function will find the factorial of x. Let's do something simpler. Let's try math.sqrt. Can someone guess what this function will do?
Find the square root.
Yes. So it'll find the square root of something. So math.sqrt, if we use again, like the help thing, it tells us returns the square root of x, right? So that is how we decode what does something do. So let's say if you're like looking, like the reason why I'm telling you this is sometimes we will end up reading someone else's code and we may not understand what a particular function is doing. So Python has this inbuilt help to assist you in telling what something does, or how something happens, right? So math.sqrt, and then if I type in 16, anyone, what will we get? 4, right? So we're just taking the square root of 16, and the square root of 16 is 4, so we get 4. Similarly, there is this function called math.pow, which is, again, let's see what it is. So this is x comma y, it returns x star star y. And we did this in our first class. Star star is essentially returning the power to something, right? So we want math dot power 4 comma 2, and then this will give us 16, right? So this gives us the reverse of that. Cool. So that's how, so that's just an example of one library, right? And that's how we use libraries. Now there are different ways to import libraries. Let me restart my kernel before I show that. So I just did quit, which will essentially close this, so close the original console, and then it's essentially restarting the console. So now we have a fresh console. So now if I do import math as empty, this is something which you will very commonly see in Python programs, people writing import math as empty. Let's see if we can guess what this is doing. Can we tell me what will happen if I do this now? Anyone?
It will throw an error.
Why do you say that, Taha, that we'll get an error?
Because we have named it as empty, like we have to put in empty square sqrt.
Right. That's exactly right. So it'll throw an error. And what is the error now? So the error is a name error. It says math is not defined. And why is it not defined? Because we've actually changed the reference to math from just math, but now we are saying it is being imported as empty. Does that make sense to you, everyone? So like, how do we then use, so let me ask someone else other than Taha, how do we use the square root function now? Also, Gopalakrishna has a question: does it return in float format only? So I guess like because most mathematical operations will tend to like, might have a float return. So when we were doing square root, then you can have a decimal square root. So yes, the default type is float. But if you want to convert it, we can we'll talk about that. It's not necessary right now. But if you would wish to convert like a float to an int, we can do that. But generally, yeah. So generally, when you're doing math operations, you prefer your variables to be float, and Python sort of handles it automatically. So like it doesn't have problems. So if I have a variable int, sorry. This is, so if this is my variable, I went a little Java on that. So this is an int type variable. And now let's so as I was talking, so once we have to use the math function now, we use this name empty because how did we import math? We said import math as empty, right? So we are using empty here, an empty dot square root. So what I was trying to show you was that we know this will return float, right? So this returns float. This was 4.0. So now instead of doing a type, let me do empty dot square root multiplied by a. So we are doing a float times an int, and that so Python inherently doesn't have that issue. So if you were concerned that the result is a float, and then if it's not, like if I'm interacting with an int, then what happens? So that's no problem. Python can usually do that. Okay. So is it clear that how can we import something and how do we name something? Is that clear to everyone? Yeah. Okay. Let's try something else. Let's say, so we started with like trying to find out an area, right? So if the radius is 9 and we want to find out the area of a square, then let me restart the kernel once more. Just this one last time. Oh no, Python isn't responding to something. Okay, good. All right, now, so we did import math, right? So now let's say if I do this. Well, that should not. Oh, sorry. Yeah. So let's say if we do this, now what happens? What will happen if I do this now? Any guesses?
We will only use the import the py function from the math library.
Yes. But Ramcharan, did you also have a comment?
No, I don't have a comment. I asked first, the max already was imported because you are working on the new one like that.
Yes. So since we are working on the new one, now like everything we did before has been scratched out. So math is no longer in the library. Now the only import I've done is this. It's just this from math import by. And then yes, so like Taha was right that when we do this, the only thing we are importing is pi. We are not really importing the whole library. So sometimes if you just want to use one particular function of a library, so you don't need to overload sort of your console or your program with like all these new additions or all of these new functions. We just want one function, right? So if we do this, then we'll get an error because math is still not defined. Or the only thing that is defined is pi. And then again, using the same concept, we have area is equals to, let's say if the radius was 9, so you do 9 / 9 and then, right? And then this will work. And the reason it works is because we have imported pi. But if we did not import pi, then that will not happen. And then same as this function. So if we do from math import pi as p, now because I have not refreshed the console, pi is still in memory, but let's pretend it's not. And now if we need to use area, then instead of pi, we just write p. And then we'll again get the same thing. Right? So it works. So like these are, so basically I taught you, like we went through 3 keywords: from, import, and as, right? Import is what is used to bring something in. And then what it is bringing in, it can bring in a whole library. If you just do import math, then we'll get the entire library math. But if you use a from before it, and so then you specify after from, you specify the library name. And then once you specify the library name after from, then you specify using import what function or what attribute you want to import. And the as is the name that you would like to use, to refer to this function or the entire library, right? So that's like just a very brief, quick introduction to how we use libraries and how we import them, and then how we work with them, right? Okay. So that was agenda 1. Now let's move on to pandas. So what are pandas? Pandas are, so like this is a very, very common line that you will see. So pandas being imported as PD is sort of like a standard thing. So this name is, you can use any name here, right? You don't have to use PD, but like there are some standard ways, right? Like how when we use area, we use R for radius, and we will not use like a random name variable name. Similarly, for pandas, people generally tend to use PD. So it has been like, so this is convention. This is something that people use or people have always used. You don't have to, but it's nice if you do, because then people reading your code would know that, okay, this is what you're doing with it. So, but what is pandas? So pandas is Python's construct or Python's library to deal with data sets, right? So if you have tabular data, so which we economists generally would use tabular data in a lot of settings, like all our data sets are tabular. So you have variable by tabular. What do I mean? So there are rows and there are columns. So it's a table. And then columns are usually variable names. And then rows are usually your instances of each data record, right? So let's do like a random example, right? So like we had dictionaries yesterday. So like for pandas, we can again use dictionaries to feed them. Let's see how first. So let me actually first show you. So DF is again the common terminology to refer to a table name or a data frame, but then you can again use something else. And the function to use that is called data frame, right? So can you all see this pop up now? The gray pop up with like white font that I'm seeing on the screen.
Yes.
Yeah.
Yeah. Okay. So this is Python's way of helping you with, like, when you're trying to write something, then this is Python's way of helping you. And then this will change across IDEs. So Spider at least shows you the entire function and then what all can you do with it, right? So it says there is like this option of data and then index and whatnot, right? So we'll go through these one by one. But for now, if I just do, like, if I don't put anything, if I just do an empty thing, then what is data frame? Like, what is DF? So it's an empty data frame right now. It does not have any columns. It does not have any index. Index is what Python refers to as rows, right? So you have rows, which are called as index in Python. And then columns are just like what we normally understand as columns. So let's create a data set, right? So you can create data sets multiple ways. You can manually create one. You can use a dictionary to create a data set. You can use like existing files, which you will. So normally the way you will use a data set is you will have an Excel file or a text file or some sort of file, right? That you download from somewhere. And then you use that file to bring that data into Python. Or maybe what we will do in this class, like later on, would, like not today, but like in future sessions, would be we would like scrape data set from the internet and then we would construct our own, right? So, but first, let's see how do we make a data set. So I am currently using a dictionary, right? And I'm going to create a very meaningless data set. So this and then AB. Okay, so that's the dictionary. Now, very quick recall. What are the keys of this dictionary D? Keys.
ABC.
ABC, right? So D dot keys. What are the keys? ABC. Correct. Right. Now let's try to create a data frame from this. So I just passed D, just the dictionary in the data frame, right? Let's see what happens. So this is our data set. You see, ABC become the column names, and then we have 1, 2, 3, 4, 5. So A was 1, 2, 3. So like these are 1, 2, 3, and then B is 4, 5, 6, and C is 7 and 9. And let's like do a more meaningful one. For example, if let's say we have names, and then we have I don't know, if we have like marks, and then if we have like gender, like let's say this is like a simple, I don't know, like some sort of tabulation. And then for names, let's say we have Jack, Bob, and then oops. And then we have marks. So let's give these people some more. And then we have gender. And I did what people do generally, have all male names. So let's correct that. And let's have a female there. Okay. All right. So a little meaningful, then let's do this again. And now let's see what this is, right? So we get this data set. So we have like 3 people. So this is a data set for 3 people with their names, marks, and gender, right? So we constructed this data set. That's very simple, right? So if you have a dictionary, this is how you can manually create a data set. Now let's do something else, right? Let's try. Let's say we have a missing data problem, and then let's say we have let's say we have marks of another student, but we don't have their name or gender in this, right? So this is an asymmetric dictionary. Now what happens? Can anyone guess what will happen if I try with this now? It's not obvious, like it's not unlike the other questions I've asked. But would anyone like to take a guess as to what will happen?
It will be empty. Like
Empty. Why do you think that will be empty?
oh, sorry. There is one additional entry here. Oh, sorry.
Okay, so let's just see what happens. So now it gives me an error. It says all arrays must be of the same length. Now, tell me why, like what, don't tell me why we got this error. Tell me what this error means, right? So this says value error, all arrays must be of the same length. So what do you think is the problem? Like, what does this mean? Just try to like take a guess. Yeah,
We
just
have
this information.
extra length in the one array. The array will be 3:3 because
Yes, go on.
after Jack
Yeah.
we have 40, 50 and 60. We have 70 which we don't match any name now. It was
Right.
extracted. Yeah.
Right, exactly. So we have like this extra variable, like we have this extra entry in this array for marks. So like this is a 3-length array, then this is a 4-length array, and then like the last one is a 3-length array. Then what is an array? It's like similar to a list. For now, we can ignore like what it is. Like you can just think of it as a type of a list. And then this is what's happening. So like the first one, the first column will have 3, the second column has 4, and the third column has 3 again. So like Python does not understand what to do with it. But there is a way, if you have like a data set like that, there is a way to write this. So first, let's see, what will this give us? And also like Python also tells you what is this. So it's an object providing a view on these values. But like, what do you guys think? What the output? What will be the output when we do this? Okay, no guesses. Let's see. So these are the values in the dictionary. Right? So like now you get. So you see this double like double parenthesis or double square brackets. So the first. So these are the lists, right? Or these are the arrays which we had in this dictionary. The first one is the names array. The second one is the marks array, and the third one is the gender array. So basically, it tells us all the arrays, and it takes out the keys, right? And then how do we get the keys? Then this is how you can get the keys, right? So now this tells us the keys. These are dictionary keys, names, marks, and gender, and this was dictionary values, right? So we get all the values, and then we get all the keys. Cool. So that's what's happening with like these two functions. And then we are going to use these two functions now to make our data frame, right? So data frame was pt.dataframe. Now let's see this. So there is an option of specifying what is our data, and then there is an option of specifying what are the columns that we have, right? So there are like these two options. There's data, and then there is columns. Cool. So let's use them. So we say data is equals to d dot values, and then let's specify columns. Columns equals d dot keys. Okay, so I think like we have to specify what access, but like we'll get to that later. So like let's move one step at a time. So now we just use the data values, and then this is what happened. So this got one thing that happened was this got flipped. Now we have names in the row, and then you have marks in the second row, and then gender in the third row, right? And then, but like it's still corresponding. So like the last one was missing, and then that is what's happening. It's missing, right? So that's how you can construct a data set which is not. But then if we want to flip this, how do we flip this? So then there is this function, right, called transpose. Now I just guessed this function. The reason I used this function was this function is like in, so our columns became our rows. We want the rows to become columns in math, like when you have a matrix, and when you need to flip it on like one edge, then we call that transposing the matrix. So that is what the function does. So what is the function? It transposes index and columns. So index, again, just remember, like we talked about this, index are basically rows, and then columns are columns, right? So what this does is it changes the index to columns, and then this is like a whole help thing that Python gives you. And you can like see examples and all. Right? So let's do this. Let's basically, oops. So let's do data frame dot transpose. And now we have flipped it on its head again, right? So now we get it in the form that we wanted it by using transpose. But so what is the data frame now? Is it changed or is it not changed? Right? So this is like a new concept that we're going to talk about. We did transpose it, but the data frame still stays the same. Can anyone take a guess why? Anyone? So we did transpose it here, right? We said data frame df dot transpose, and then we could have received this changed matrix, which we would have liked. But
Not stored in DF. Like there is transpose function applied to the DF,
right,
but it's not stored there.
exactly. So this is like a concept that we need to understand now, that sometimes in Python, like, so now this varies with each function, right? So like, let's again see what transpose functions help says. So what does it says? It says reflects the data frame over its main diagonal by writing rows as column and vice versa. The property is an accessor to the method, whatever, right? And now this is what it is. So copy is by default false, right? So there's an option that you can provide, which is called copy, which is by default false. Okay. So what do you think it means? And it says right here, whether to copy the data after transposing, even for data frames with a single data type. Note that a copy is always required for mixed data type data frames or for data frames with any exchange steps. So we'll ignore that part. But then for this part, the copy default is false, right? So let's try and see what happens if we use copy equals true. Right? Now what will happen? Changed or will it not have changed?
Changed.
Still does not change, right? So that function, it creates a copy of it, right? What this essentially means is, I think, so like, let's see this. So if we do this versus if we do that, then there might be like a difference between how this works. Right. Now data frame 1 is this, and then data frame 2 is this. So these are both the same data frames, right? And those are both, one is a copy, and then the other one is not a copy. It's just like whatever that is. So in Python, the word copy means something, which we will get to later. There's something called as a shallow copy, and then there's something called as a hard copy, right? And now let's talk a little bit about like copying data sets. Okay. So we have, let's go to like a very basic example of dictionary first to try to understand what's happening, and then we can move on to that. 6, and then 7, 8, 9. Okay, so it's very simple. That is what a dictionary is. It's A is 1, 2, 3, B is 4, 5, 6. And then C is 7, 8, 9. Okay. Wait, like before I keep moving on, now does everyone get how do we create data sets and how do we transpose them? We missed one thing, right? So I showed you that we got this, but we still don't have column names. So how do we get column names? It's very easy. It's almost intuitive, right? So you do df2.columns equals, and then you pass on the column names. So the first column is names. The second column is marks, and then the third column is gender. Right. That's right. It's not gender. Okay. And you see, this is what happens, right? So we accomplished what we, so originally what we did, like, so if you have a balanced dictionary, then you could have just, referenced it in one go. But if you don't have a balanced dictionary, then this is how you sort of do it. Okay. So now is everyone clear on how can we create a data set from a dictionary?
Yeah.
Yeah, makes sense. Okay. Now let's get back to what we were talking about, copies and dictionaries, right? So our dictionary D has this form, right? So it has a column A, which has 1, 2, 3, column B, 4, 5, 6, column C has 7, 8, 9. Now let me create a D1, which is, or like, yeah, let's call it D1. So D1 equals D. So that's one way to create a copy, right? And then D2 equals D dot copy. Let's actually see what all functions does the dictionary provide, right? The dictionary provides clear, from, keys, items, pop, default, values, update. We have already used values. We already used keys. Now let's see what copy is. So what is a copy? It's a shallow copy of D. Now what does shallow mean? We'll talk about that right now, right? But like, let's first use something to create a, what it is calling a shallow copy. Okay. So now we created a shallow copy D2 and we created D1. Now let me do this. Let me add a new key to D. Now what do you, so D is this now. Now what do you guys think happens to D1 and D2? Like what is D1? Anyone? So we stored D in D1 before, right? And now we changed D. So the first thing we did was we had D, which looked like this. Then we said, okay, make D1 also as D. So make a variable, like we created a variable D1 and we called that will equal D. And then we did like this functional thing to create that. So what do you guys think happened with D1? Go on, take a guess. Yeah, Akash?
D is added like D000.
Will
It will
also
be
be there.
added
So
up.
like
Yeah.
D1 will look like D.
Yep.
Can you like try to take a guess or like try to tell me why do you think that will happen?
I think like the command D1 is equal to D. That's kind of, it will remain intact. Whatever changes in D will be stored in D1.
Okay, let's test. You're absolutely correct. So what this command does, and it doesn't, so like for primitive data types, let's try this. So if A is equals to 3 and then B is equals to 6, and now if I change A is equals to, let's say if I do whatever A was plus 2, then A is 5, but B is still 6, right? So, oops, I mean it will be because I did not do that. So let's do B is equals to A, right? And now let me do this again. A equals 2. Now A is 7 and B is still 5, right? So here it does not happen, right? Here, like B does not change with A, but then like, so we assign B to the value of A, that does not change. But here it changed, right? And this will happen when we are using complex data frames or complex, like, data types. So just this number 3 or this number 6 or like a 6.0 or a name, those are like primitive data types. So primitive data types being like int, float, string. So like very simple data structures. This is a complicated data structure. It's a dictionary which like has levels, right? So D is a dictionary. And then what is a dictionary? A dictionary is a complicated data structure which will have like, which has keys, which can be anything, right? It can be int, string, whatever. We did this with Saket. It can be anything. And then each of these can store anything, right? So like here I have a dictionary whose keys are sort of a string, and then each of the keys contain a list. So it's a complicated data structure. So whenever we are dealing with complicated data structures, you cannot create a copy by doing this, right? So if we do something like this, D1 is equals to D, then Python is not creating a new data frame, right? It's merely telling, so whenever you use D1, it's simply pointing to D. So you remember how we did this? We said import math as empty. And then whatever empty was, empty is no library in Python, right? What empty does is empty points to math. Does that make sense? So empty is the name which we use to tell Python that we want to access math. Similarly, when we are writing d1 is equals to d, all we are doing is we are telling Python that when we use this word d1 or this variable name d1, take us to d. So these are bound, right? So d1 is this and then d is this, right? And let me now do this. Let me now add an element to d1. Now, what do you guys think happened to d? Take a guess.
E is added, but
E is added. So like there are only two things, right? One E could be added and one E could not be added, right? Let's see what happens. So E is added, right? Because this statement, what it does is it binds both of them together. It just says that D1, like as I was saying, when we are doing import math as empty, when we do this import math as empty, then empty gets bound to math as like, its thing, but it's not the same because now we cannot do math. I'm just telling you as an example that this is how you created a reference to something. This keyword as creates, like empty is your reference to math. Now, when you do this, d1 equals to d, then you link these two variable names. You basically say that, this is the same as this. So, which is why when you're trying to like create new variables or create new data frames, which will link something like that, like we have our original data frame, right? So this is our main data frame. Like, let's say for some reason you want to create a data frame that looks like this. If you will create it like this, df3 is equals to df2, then that's not a very good practice. Because what this will do is this will simply create a new reference to df2. So think about it like this. You have this data set in memory. The way to reference this data set is by typing df2. All this line accomplishes is it gives you a new name. Like it gives this data set two names basically. Now you can refer this data set with the name df2 or df3. Clear? Makes sense?
so does this generally happens like first I thought that if d1 is equal to d, then whatever changes in d will be stored in d1, but not the other way. But in
Right.
Python, the other way is also happening. So does this generally happen
Yes.
in all the languages, like R or Stata?
No. So this is a very Python specific thing. Like I don't use R, so I don't know if it happens in R or not, but it definitely does not happen in Stata. So Stata works on like a different sort of like an underlying system, but this is, yeah. So like this will happen only in this. It will not happen in Stata for sure. R also I'm inclined to say it does not happen in R either, but I'm not too sure. So like if Saket, if anyone knows, just help me out here. But like I don't think it happens, but yeah. Or if anyone of you knows that you have seen something like this happen. But the point being that this will save you a lot of time when you're trying to debug. Like these are the kind of basic functionalities that you need to know. That if you're creating a copy, like this seems very intuitive, right? Like if I want to make another copy of df2, I should just say, okay, df3 is equals to df2. What's the big deal? There is a big deal, and the big deal is that it'll just link this to there. So like if you then change anything in df3, it'll also be stored in df2, and then the whole point of creating a new copy to maybe experiment something is like defeated because it's changing the original thing also, right? So this is why we should not use it like this. Cool. Make sense? All good? Okay. Other people? Like, let's see a thumbs up from everyone before we move on, just to make sure everyone is on board with what's going on. Okay. Ramcharan, Komal, Akhil, all good? Okay. All right. Do we have Komal with us? Okay. All right. Let's keep moving. So this was one thing, but I showed you another thing, right? So now we know that this is simply creating a reference to D. So it's not really creating a new copy or anything. It's just creating a new reference to D. But there was this thing which, so Python says that this will give me a shallow copy of D. Okay. But what does a shallow copy mean? So now what was our D? So our D is this, right? So it has A, B, C, D, E now. Let's actually go back to what D originally was. Okay. So like this is what a D is, and then let's do D2 is equals to D dot copy, right? And now D2 looks like D. Okay. Let's again do what we did before. Let's create a new key. Now what happens to D2? It does not support that, right? So this, you see this? There is no new key in D2, whereas in D, there is a new key. But then Python says that it's a shallow copy. So what does a shallow copy mean? So if you just like, if you were to do like a quick search on what is a shallow copy, you will, the result that you're most likely to get about like Python and shallow copies is, it's still a reference. Like even for D, Python did not create like new spaces, right? So what happens in the background? In the background, there is like a memory, right? Where Python is creating all of these elements. So it's creating these keys. So it'll create a key called A. Then it will link this 1, 2, 3 array to A. Similarly, it'll create another array B, and then it'll create it, link it to that, and then similarly to C. So it is doing all of that in the background. And then this whole data structure, it names it B2. What a shallow copy does is, it again creates a reference to this data structure. But what's happening is, in a shallow copy, when you create a shallow copy, it's not linking to any new data structures, right? So like within D, there was ABC when the shallow copy was created. You add D later on, it does not care. It only cares about ABC, right? And then similarly, if I were to create, if I were to do this, so if I were to create D2, and then if I were to put this in D2, now we have D2, and in D again, so these parts are different, but these parts stay the same. Okay, this is what has been copied. Cool. So does this mean that this is a good way to sort of create a copy? No, because there is still a problem. What is the problem? Let's see. So now I said that D2 is a reference to the original elements. So let's try and change the original element. Right? So let me do this. So A, and then for the second element, or for the second element of A, right? So what does this mean now? DA1, 1, what will I get? Just as a refresher.
Might be 2.
Yeah, it's 2, right? Because this is 0, this is 1. So now, just to check, this is 2. Let's change that to 20. Right? So now in D, this is what the new array is. Now what happens in D1? Oh, sorry, what was it? D2. You see, this changed. This is no longer 2. So what is a shallow copy doing? A shallow copy is still creating references to the original elements, ABC. So if you change anything in the original elements, then the copy will, like, it will also be changed in the shallow copy. And again, you're not getting a true copy. So this is not like this is not a cloned copy. This is like basically they're still linked at some level. And again, that can create problems when we are trying to create a fresh copy. Okay. So how do we create a fresh copy then? There is this library called copy. Or maybe, yeah. So there is this library called copy. And then there is something called as a deep copy, right? And now let's do this. So let's create D3 and then let's say copy.deep copy T. Right? Now we have D3, which has these elements, and then we have D, which has these elements, right? And let's quickly check if it did what we wanted it to do. So -1, 0, 1. And then D has all of these keys. Does D3 also have these keys? No. So, but this was happening also with the shallow copy, right? So let's do the final check. Let's change an element in, so like how we change this element to 20, let's change that to 30 now. And let's see. So this is our element, this is our dictionary D. This element has changed. Let's see if it has changed in D3. It did not change. So this is in a true form what you want. So every time you want to create a deep copy, like every time you want to create a copy, you should make sure that you're creating a deep copy. And if you're not making a deep copy for whatever reason, you should know that these two data sets are linked. Makes sense?
Yes.
Yeah. Any questions? No questions?
In the shallow copy, like to the D, it changes the D3. But when we make changes to D3, will it change the D? Like, what's the purpose of shallow copy then?
So like the purpose of a shallow copy is essentially, so like sometimes we don't know why we are creating a copy, right? Like there might be a complicated data case in which you want to just refer to both the things, right? And then, so you want to like you don't want to add new elements to it, but you want to change the existing value of the elements. And then, but if you add new elements, then you want to, so you want a departure. Let's say if you have a data set in which you are now adding new values, but you want to store the original values somewhere, right? So you stored the original values and now you're adding new rows to it. So you keep adding new rows and then that will keep adding in your shallow copy and it's not adding in the original data set. But now if in the shallow copy, you are changing these values based on some condition, right? Like let's say if you're saying that, everyone who had marks less than 50, let's give them a particular assignment. And you want this to be reflected all the way through. Do you see what I'm saying? So like there are appended rows. So there's a data set with 10 rows, and then you add 10 more rows to a copy of this data set, a shallow copy of this data set. So this is a bigger data set of 20 rows. And then you go back, but you want the changes that you're making to these 20 rows, the logic of changes to be also reflected in the original 10 rows. I'm just giving you a random example. I've never had to use shallow copies. The point I was trying to make is like for at least the applications that we use, we should be always using deep copies, because whenever we want to create a copy, we want to create it for reasons that we don't want them to be linked, right? You want to do something else completely with it or something like that. So that's why we use deep copy. But if you end up with an exercise, like I just tried to think of this one example in which we need shallow copy, but you may not need shallow copy at all. Right? Does that answer your question?
Yeah, thanks.
So Gopal Krishna has a comment. Is it like deep copy retains original data set but just can add new elements but does not change what was originally given? It retains original data set but just can add new elements. So Gopala Krishnan, deep copy is like something which is completely new, right? So when we are creating this data set, like when we create a dictionary, how we write, like we basically first we are creating keys and then we are creating all the values in it. So Python is creating this whole memory block for that dictionary. When you're creating a deep copy, Python creates another full memory block. It has nothing to do with the original one. It's taking each of the elements of the original data set or the original data type or whatever the data structure is, and then it's just creating all of these elements again and again and again. And that is what it is doing. It's not creating anything. It's not linking anything. It's literally creating, it's like, think about it like creating a clone. You create a clone, so it will have all the properties that that person had until that point. But from now on, the clone has its own experiences. The clone can change its own memories. The clone can do whatever to itself. And then the original person will continue to have its own life, right? So they reflect, they're exactly the same at the time of cloning, but after that they are very different. And then that's what this, so that's what happens with this, right? So that's what a deep copy is. It's completely separate. It's what we would want to do. Okay, so that was about copies. And the reason we did this is because we would sometimes want to create like copies in DataFrame. So we should remember that if we want to create a copy in a DataFrame, or if you want to create a copy of a data set, we need to use this copy thing, like what I just showed you, this library, which is import copy, and then use the deep copy function of copy to sort of use that. Or basically just verify if, so like let's say dataframe.copy, does it have, yeah, so it has this, right? So it says make a deep copy. So in Python, whenever there's a copy function, just make sure what it says. So this says that it does make a deep copy, including a copy of the data and the indices. But you can set deep equal to false, and then it will basically not create a shallow copy, right? When deep is equals to false, a new object will be created without copying the calling object's data or index. Only references are copied. So references are basically arrows which are pointing to that, and then to the original object. So that's what a shallow copy does for you, right? And when deep is equals to true, a new object will be created with a copy of everything. So when you create a copy of everything, you create a new thing. Cool. So that is what. So in a data frame, you don't need the copy function basically, but like the point is that you should always verify what you're doing makes sense or not. Okay. So any questions before we move on? Or more questions? Nothing? Okay. So we now know how to create a copy of a data frame. We know how to create a data frame from a dictionary. Now let's see what our original data frame was, right? So this is, so we created a new one, right? With transpose, was it? So it's data frame, right? So that is what our data frame looks like. And it has this missing one, but we're fine with that. Now let's say if we want to just see, if you want to see people who scored less than 50 marks, right? How do we do that? So we do df2, and then we do the same thing, right? Like let's say if you want to just see rows 0 and 1, let me actually ask you this. What will happen if I do this? Come on, take a guess. You know, we did lists. Yeah,
It will only show the second row.
then what will happen if I do this? So there is a colon before 2.
It shows till the second row.
Does it include the second row?
Yes.
So will it show Trenton? Will it show Robbie? Like what will it show? It will show the first one you're saying, and then the second one is Robbie. So it will show
No,
just these
0
two
and
rows?
1.
Just 0 and 1. Okay, let's see. That's exactly right. It just shows 0 and 1. So this is how you can reference a data set. So it's very simple, right? It's just doing this, right? Now let's say if I want to, I mean, it's a little difficult. So now let's say if I want it to show me just the names in the first 2 rows, what should I do? Just want to see the names. I don't want to see other things. Like it's showing me the complete data set, right? If I just want to see names, what should I do? Does this seem intuitive? Let's first do this. So if I just do this instead of the rows, if I wrote names here, then Python understands that you're referring to the column called names. And then it just returns you the column names, right? Similarly, if I will to do this, then since this indicates the first two rows, right? These two. And then what is names going to do? Names is going to just tell me the names in the first two ones, right? Make sense? So that's how we are like seeing our data sets, right? If you want to see the names in the second row, but that will hardly happen that you want to like, see the name of the first two people. And if you want to do that, there are more functions for it, right? There is a function called head, and then you can specify. So returns the first n rows, right? So what is n? I specify 2. What will happen? Anyone?
It will return name
Let's
marks.
read it again. So what is head doing? Oops. It says returns the first n rows, and n is the parameter that you pass in the function. This function returns the first n rows for the object based on position. So what will it do? So if I do this,
It will return names and marks, the first two rows.
names, marks, and the gender, and basically it just returns the first two rows of the data set, right? Similarly, if I do this, what do you think it will do? So head,
N and N, like
right,
the lower part.
right. So if we do tail, then we can do the lower part. So like this is like a quick way to see what is in your data set, and then you can basically specify as many rows. So if I specify this, then it just returns me everything because I want like the last 20 rows, but there are just 4 rows in my data set. So like the complete data set gets returned. Cool. So this is how like you see your data set, right? So if you want to just quickly see, there are these functions, and then if you want to like specifically see a particular column and then values in a particular column, you can do that. But let's say I want to see people whose marks are like in this data set is difficult to do. Let me actually change something or not. We'll change it later. But let's say if we want to see the marks of people, like we want to see the names of the people who scored less than 55 marks, right? So what do we do? Instead of this, I mean, this is the same, but we need a condition, right? So the first thing is let's try to get a condition. So we know df2 marks is going to tell us the marks, right? And now let's say if I say marks less than or equal to 55, what will this return? What will I get? Just take a guess. So let's do something first. What happens if I do this? What will I get? 40 is less than equal to 55. What will I get? Come on. Okay, is 40 less than equal to 55?
True. That's what we
True. Right? So that's what we get, right? We just get true. So if I do this, now what will we get? Yeah, I never asked this. Are you guys like trying this stuff out in parallel or no? I mean, it's okay if you're not trying, but it's usually good to like have it open and maybe try it out. But okay, so if you have this, then what's going to happen?
all the true values will appear, but the false value will not appear. So like 0, 1 will get true.
So what will be the output? So it's basically, it's going to tell me, it returns me a sort of like a C, like a thing, right? Like, let's see what type is this thing, right? Let's type, this is like a very handy function. So let's use that. So it's a series. And what is a series? So let's say what is the type of the whole data set? It's called a data frame. because we created a data frame. So like the whole thing is a data frame. And then if I just do this, then this is a series. So one particular column in this is called a series, and then the whole thing is called a data frame. And like just so you guys know like what is the type of this, it gives me a key error because you cannot provide, like you cannot access rows like this. If you provide just one, it does not know what you're talking about. It will probably think that 0 is the name of a column, and because 0 is not the name of a column, you will get a key error. Okay. So, but we were talking about this thing, right? So this is a series. And we just learned that basically a series is nothing but a column, right? Which is also what we see here. So it's true, true, false, false. So it's a column. And a column with values true, true, false, false. Okay. Now, let's see what happens if I do this. Okay. So you remember how we did this? So we originally what we did was like we did this, right? Colon 2. And you guys said we will basically get the first two rows, so 0 and 1 rows. Why? Because this is saying that, okay, give me 0 and 2, 1. Now, I'm not telling it what to give me, but I'm just passing this column. So I'm basically, for each row, I'm saying either true or false. So for the first two rows, I'm saying true. And for these two rows, I'm saying false. So what do you think is going to happen? That's right. So we basically get just the first two rows. So the true ones appear and the false ones don't. So this is how you basically pass a sort of a value to something, right? So this was our whole data set. For these two rows, this condition was true. So we filtered out these two rows. So if you want like a slice of the data set based on some condition, then this is what you use. Does that make sense? Any questions? Okay. Let me give you a few seconds or a minute to absorb this. So this is basically saying true, true, false, false. So in front of, so what Python will see is in front of 0, it will see a true. In front of 1, it will see a false. In front of 1, it sees a true. In front of 2, it sees a false. In front of 3, it sees a false. And then basically from wherever it sees true, it just gives you that. Yeah.
Yeah, makes sense.
Makes sense? Okay, cool. So because this was like very trivial, let's do something else now. So I know, okay, these are the columns, but let's say I want to change, like, let's say on the basis of, let's say if sex is equal to female, but let's say if you want to like change the marks for Trenton, right? Let's say for Trenton, sorry. So if names is equal to Trenton, so this is what I'm saying, if names is equals to Trenton. So we know that only for like this will be only happening for Trenton. And what we say is marks at 30. So there was a miss entry and then you want to change these marks. You'll get an error, right? So what is then, it's not necessarily an error, it is a warning. It's saying that a value is trying to be set on a copy of a slice. So this is a copy. And this is like where, you know, the whole concepts of copies coming in. That you are basically just, so this is just creating a copy. Right? First let's see what it gives us. It just gives us this thing, right? Just one row, and it is showing us the marks of that row because there is one row, only one row with the name Trenton. If there were multiple rows, let's say if instead of Trenton, if we were to do X is equals to meal. You see 40 and 64, which is the marks of the meal students, right? So you see that. So this is a copy of or a slice of the data set, which is created as a copy. So if you're trying to change values on a copy, then Python gives you an error because it's like maybe you are accidentally doing, maybe you don't understand what you're doing. So what it says is, if you want to create a value, if you want to change values, then you should use this function. Try using this instead. So try using .loc, row indexer, column indexer is equals to value, right? So if Python is telling us to do that, then let's do that. Basically, let's use this function called LOC. And now, so this is our row indexer, right? Like we want the names of Trenton. And then what is our column indexer? We want to change marks to 30. Let's see what happens. So the name, so the marks have been changed to 30, right? So that is how you will change, you'll end up changing something. Now, let's say if I want to create a new column called pass fail, and let's say the passing marks are 45. And if I want to create a new column, what should I do? Are you guys like, someone tell me? So basically the object is, I want to have another column here which says grade or something like result. And then I want the result to be like fail for those who have less than 45 marks and who have more than 45, pass for those who have more than 45. So what do I do? Any guesses? What did we do when we wanted to create a new element in the dictionary? We just did this, right? So let me show you very quickly what do we do. So like if df2, we want to do a result column. And let's say if I say it's like that, what will happen? Let's see what happens. You see, there's a new column with a value passed for a key. That makes sense. Like that's how you create a new column. Like usually it's very intuitive, right? So in Python, this is like a reason why we use Python, because everything is just so intuitive. This is like, okay, Python will go in, it will see that, okay, there is no column called result. So it will create a new column called result. And then you're assigning the value pass. So it just assigns everything to pass, right? But now we want like a conditional assignment. So let me first see, like, let's first see how do we drop this, like how do we delete? So deleting, there is another word called drop. So let's see if there is this function, right? There is this function. And then drop specified labels from rows or columns, right? So remove rows or columns by specifying label names and corresponding access, or by specifying directly index or column names. So, okay. So like you see columns is equals to BC or df drop B comma C from access 1. So this is like the rows is access 0 and the columns are access 1. Let's not get into that immediately. So let me drop columns is equals to, we just want to drop one column for result. Was something else? Oh, it's df2. Okay. So we dropped this column, right? Yeah, new people joining in. Interesting. But again, the same thing happens. It drops it, but it does not store it. So if you want to do that, then what you should do is this. You should basically rewrite it. Right? Okay. So we added a column and then we drop it. Now you guys tell me how to, the original question, which was how do you add this column conditionally? So for these two, it should be fail, and for these two, it should be pass. How do we do that?
Could put in if marks less than 50, print fail.
Mhm.
Else print pass.
But we're not printing, right? Like your logic would work if you want to just print their marks. But what we're trying to do here is we're trying to create a new column. And we want to store that information. So like how we did something like this, right? So again, let's try the same thing. We're creating this new column, but only for rows. So again, like what did Python tell us? Python told us that, okay, you can use this LOC thing. And I'm not sure if this is going to work, but let's see. So Python said that, you provide the row indexer, and the row indexer is this, less than equal to 45. And then the column indexer. So this is my column indexer. And then if this is the case, then we are going to have fail, right? And then if it's not the case, if it's greater than 45, then we want pass. Does that make sense?
What does this LOC does?
So this LOC is basically, it's telling me locate. So LOC is short for locate. So locate these rows, right? So I can either tell it the index directly. So I can directly say 0, 1, 2, 3, whatever. So it's, but otherwise you can tell it which rows. So these are the rows that I want to do something in, right? So these rows and these columns. So this can be one, these even can be multiple columns, right? So like just as an exercise, if I want multiple columns, you can also write something like this. So let's also, this doesn't make any sense, but like let's also, let's create another column, right? Let's say result. Right? And instead of class, I'm just going to write, and then I'm going to see this, right? So you see how result changed, like these rows changed to P, and then this new column was created because I added this new column. And then nan basically means a missing value. So because we have not told Python what to do with people whose values are less than 45. So for greater than 45, we said put at P. So it's P. So LOC, so what is this command doing? So it's going into DF2. So dot basically says that everything that precedes it, go into this. So DF2 dot means go into DF2, locate these columns, sorry, these rows. So locate the rows where marks are greater than 45, and then locate the columns, these columns. So if they exist, Python will locate them. If they don't exist, Python will create them, right? So like result2 did not exist here, so Python created it. Result existed, so it accessed it. And then change whatever value there is. So this equal to is value assignment operator. And then we assign the value P to them, right? And that is what happens. Make sense? Okay, questions? Yeah, Taha?
Yeah, it makes sense.
Yeah, makes sense. All right, so we are in time, and we covered what we thought we should have covered today. So, okay, so just to recap, now what do we know how to do in, like, we know how to, like, basically build a data set in Pandas, and we know how to view values. We know how to view values on a particular condition. We know how to assign values, and then we know how to change values, right? So now if you have a data set, and based on some condition, if you want to change things, you can do it. So in Stata, for example, if you have a data set on something like, let's say, fertility or something, right? And then if you want to create new variables based on that, you write generate x equals to a times a or something like that. So you can do all of those things in Python also. The only thing is instead of x, it will be, where are you generating? df2. What are you generating? You're generating this variable x. And what is this variable? So this variable is simply going to be, it's going to be marks divided by 2, right? And then if we go to df2, now notice how I did not use LOC here, because it's not a conditional assignment on a slice. Like when we are generating on the full data set, you don't need to provide LOC or anything like that. But if you still want to like keep it consistent and keep it simple, then you can provide LOC, and then you can provide a colon here. And then instead of divided by 2, let's say multiplied by 2. So that it just changes, right? So what does this colon do, this empty colon? Anyone? Very quickly. And then we'll end. So, okay, so if we have a list, 1, 2, 3, 4, 5, and if you provide this, then you basically just get the entire thing, right? So if you provide a number at the end, that says, okay, the first 3 elements, 1, 2, 3. If you provide a number in the beginning and nothing at the end, that means till. So if you don't provide anything at the end, this means till the end. When we provided nothing in the beginning, it meant from the beginning, right? And this means till the end. So this gives us starting from index 3, 0, 1, 2, 3, 3 till the end. This meant from 0 till 3, so till right before 3. And then when you, this is why when you don't provide anything before or after, it means from the beginning till the end, right? This first number indicates where to begin from, and if the number is missing, you start from 0, and the last number tells it where to end, and if that number is missing, it means the last element. So if both numbers are missing, then it's all the elements. So that is what I did here. So if you want to keep it consistent, and if you want to specify what rows to change, you can say all rows. So this colon simply means all rows, and then the column X, and then what is the value that we want to assign? We want to assign it whatever marks that row has times 2. And then, yeah, and then that is what you get. You see the marks have changed. It's marks for 40, this is 80, 50, 100, 30, 60, 70, 40. Yeah. Okay. Any questions?